Now let us discuss the problem finding factorial of a given number. So for this also we can define a recursive function, and even using iteration, that is using loop, also we can write it. Let us first of all devise a recursive function for this one. So first I will define what does it mean by factorial of a number. See, factorial is represented with this symbol. So this means factorial of n means 1 into 2 into 3 into goes on to n. So it means factorial of 5 is 1 into 2 into 3 into 4 and multiplied by 5. So this will be 120. If I multiply all these things, I'll get the answer 120. So for n, I have to continue up to n. So for 5, I continue till 5. For 10, I should continue till 10. So just like sum of first and natural numbers, this is multiplication of first and natural numbers. That is called as factorial. And even I'll tell you one more thing, that 0 factorial is also possible and its answer is 1. So even 1 factorial is also 1 and 0 factorial is also 1. So both the results are 1. Now let us define this recursively. If I say fact of a number n is 1 into 2 into 3 goes on up to one more term I will include, that is one more number, n minus 1 into n. So in this, if I observe factorial of a number from 1 to n, this portion if I take, this is factorial of n minus 1. Yes, this can be written as factorial of n minus 1. So factorial of n is a factorial of n minus 1 multiplied by n. If I multiply that with n, then I get the result, that is factorial of n. So this can be defined recursively. Factorial of any number n is factorial of n minus 1 multiplied by n when n is greater than 0. When n is equals to 0, means for 0 also answer is 1. So return 1. That's it. So this is the recursive definition. And once you have a recursive relation or mathematical formula, then directly you can convert that recursive formula into a C++ function. So let me write down a function for this one. Integer factorial of n. If n is equals to 0, return, when it is 0, return 1. Return 1. Else return this one. So return factorial of n minus 1 into n. So the function, writing a recursive function is so easy, you can directly convert a formula into recursive function. Now same function even we can write using iteration, that is loop, right? And this is using recursion. Now, it is more similar to sum of first and natural number. If you remember in the previous example, we saw a similar function. Only the difference was here it was plus, and one more difference, return 0 was there instead of 1. Because the multiplication is there, so it should be 1. So the function is similar. Now, if we do analysis, the analysis will be same. The size of the memory required depends on the value that you're passing. If you find function of 5, that is factorial of 5, then it will be making 6 calls. So the height of the stack will be 6. So the amount of memory consumed is order of n, and the time, number of calls depends on the value that you're passing. Like for 5, it will be making 6 calls. So again, it is order of n. Just in the previous video for finding sum of first and natural number, we have done similar analysis. So I want to avoid analysis here because already we have done analysis for this one. So analysis is same. Now writing a iterative function for this one is a student exercise. So you can write down the function by yourself. So that's all about a factorial of a given number. In this video, we will see a function for finding factorial of a number. I will show you recursive function as well as iterative function. So first let us write recursive function for finding factorial. Function takes parameter n. If n is equals to 0, then return 1. else return factorial of n minus 1 with n. Inside main function, I will take a variable r to get the result of that factorial function. Let us find the factorial of number 5. The answer is 120. We already know the answer. We should get the same result. Display r. I will run the program. We should get the output 120. Yes, the output is 120. It's a factorial of 5. Let us check factorial of 4. It should be 24. Yes, it is correct. Let us check factorial of 0. What the result will be. It is 1. Let us use a negative number here and see what the function will do. Factorial of minus 1. See, when the value of n is minus 1, then it is not 0. So it will be calling itself again and again, minus 1, so it's minus 2, then minus 3, minus 4, goes on. So actually it has gone into infinite calling and terminated. So you can see total how many calls it has done. 262054 calls it has done. Then why did it stop? Because of stack overflow. So if a recursive function is going into infinite recursive call, so at one point it will terminate because of stack overflow. System stack has overflown, so it has made so many calls. Factorial is not defined for negative numbers. So if you want to avoid this recursive call, so then here you can write a condition to stop the function if the number is negative. Now I will write an iterative version of factorial. I will call it as ifact. It takes a parameter, and for finding factorial I will take f, that is initialized with 1, and also we need a variable I for iteration. Using for loop, I assign 1 onwards and I less than or equal to n, I plus plus. Then factorial is multiplied by I. So I will be taking different values from 1 to n, and it will be getting multiplied by f every time. So this will be multiplying just like 1 into 2 into 3 into so on to n. Then finally return f. F is having the result. And here inside main function I will call this I factorial function, and I will pass the parameter as 5. Let us run the program and see what the output will be. It should give output 120. Yes, output is 120. Let us debug the program quickly and see how the values of f and I are changing in this iterative version. So you can observe this watch here. Watch this portion where the values of fi will be changing. I will continue execution. It will enter into factorial function. Now the variables I and f both are there. I is 1, so 1 multiplied by f, f is also 1. Then I becomes 2, multiplied by f, f becomes 2. Then I becomes 3, multiplied by f, f becomes 6. Then I is 4, 4 is multiplied 24. I is 5, 5 is multiplied 120. I becomes 6, then it will stop. And come back to main function and print the result. So end of program. So that's all in this video. We have seen recursive as well as iterative version of factorial function.